It is the lord of the solar system. This megaworld is 2.25 times larger than all the other planets. This spinning giant emits hazardous radiation, dangerous hurricanes, and treacherous magnet fields. To give up its secrets, a spacecraft charges into the maelstrom surrounding Jupiter. Juno is part of a larger effort to look into giant Jupiter, and to see a time more than 4 billion years ago when the planets were formed and destroyed. Flung into space, or tossed into orbit. It was a time when our fate as a small, agile world was in balance. His Greek names were Zeus, Jupiter, and the Romans. The king among the gods concealed his evil activities behind swirling clouds. Only his wife Juno, the goddess Juno, was able to see through the misty veil and catch him. Juno, NASA's Jupiter near-polar orbit, was sent to Earth in order to observe the Jovian atmosphere. To uncover clues to the powerful forces beneath its swirling cloud tops. Jupiter, which is about 300,000 times larger than Earth, holds 70% of the solar system's total mass. Juno is part of a series of missions that aims to measure the planet's physical properties and determine how it became so big. Astronomers have been watching a different solar system develop to understand Jupiter's early days. The young star Beta Pictoris, located in the constellation Pictor, is growing its first crop. One is large enough, far enough from the start, to be photographed. Astronomers have seen Beta Pictoris B. On both sides. Beta Pic shows a snapshot of the solar system over 4 billion years back. The outer zone is the place where the observed planet is located. There are no planetesimals, but clouds of dust, gas, and ice. It is likely that the planet is a tornado of magnetic and gravitational energy as matter swirls into it. Jupiter, its distant relative, is also surrounded by a raging, but invisible maelstrom. The magnetic field of Jupiter, the king planet, is 20,000x stronger than Earth's. From Earth's perspective, Jupiter's magnetosphere would look wider than the full moon if you could see it in the night skies. Jupiter's magnetic zone is so big that it flares beyond Saturn's orbit like a lightning bolt launched by Zeus into outer space. Jupiter's magnetic fields are the result of a powerful double dynamo. One is deeper and permeates Jupiter's surface, while the other is close to the surface. The equator rings both. Jupiter's moon Io travels through the magnetic field. It emits powerful radio waves strong enough to detect on Earth. Io's volcanoes emit a flood of charged particles in this field. These charged particles, in turn, ignite huge auroras that illuminate the poles of this vast world. The planet is enveloped by a cloud of charged particles, which creates a radiation belt that emits radiation 1,000 times as deadly to humans. Pioneer was flying by the radiation belt in 1973, as it passed 130,000 kilometers of Jupiter's cloud tops. Pioneer 11 made the first close-up of Jupiter's enormous signature storm, the Great Red Spot. It was a year later. The design of the twin Voyager spacecraft was influenced by the Pioneer's discoveries. Engineers protected critical components of the Voyager from radiation during its launch in 1977. The Voyager craft captured nearly 19,000 images, including new views and perspectives of Jupiter's ghostly rings. The icy terrain of Europa and Ganymede's big moons, as well as the powerful active volcanoes that erupted on Io, its inner moon. 1995 was the year that the Galileo mission came closer. Galileo brought back a treasure trove containing discoveries about Jupiter's atmosphere. Jupiter's composition is nearly identical to the Sun and offers a glimpse into the origin of the solar system, around 5 billion years ago. Stars and planets can be born from clouds of gas and dust that contract. These contractions are often accelerated by an explosion of a nearby star. A shockwave from the star that is dying causes the cloud to burst and then spin. Temperatures rise enough to form a dim protester when matter flows into its center. Millions upon billions of small dust particles collide within the disk and stick together to form sand-like controls. These controls, attracted by gravity and static electricity, join together to make pebbles. Pebbles turn into boulders. And lastly, planetesimals. These kilometer-sized objects can collide, causing them to stick together or fall apart. Matter flows into the central star while it is still dark. As the star gets brighter, radiation and winds blur the edges, pushing gas and remaining dust outward. Priceline is located some distance away. It's where temperatures are sufficiently low to allow water, carbon compounds, ammonia, methane, and ammonia to form crystals. Here, the protoplanets form quickly from objects made of rock or ice. The largest objects grow the fastest through this process. Juno's electronic circuits had to withstand Jupiter's harsh radiation. To do so, they were enclosed in a titanium vault. Its components were constructed of radiation-hardened material. Juno is covered in lead foil. Juno, officially known as the Jupiter Near-Polar Explorer, was launched on August 5, 2011. It was the second launch of NASA's New Frontiers program. These medium-sized missions are designed to expand our knowledge of planetary bodies and give new insights into how the solar system originated. New Horizons was the initial mission. It traveled for 9.25 years to reach the outer solar system. It mapped Pluto's surface and Charon's moon Charon. It also collected information about their geology and discovered clues to their violent and complex history. OSIRIS-REx 3, also known as OSIRIS-REx, was launched in 2016 to an asteroid named 101955 Bennu. The mission was to actually land on an asteroid and retrieve rocks from there. These samples will be used to answer basic questions not only about how the solar system was created, but also about the origins of organic molecules that triggered the evolution of human life. These missions each faced challenging technical challenges in order to gain important science. Juno faces the challenge of flying close to Jupiter while not getting burned by Jupiter's powerful radiation belts. To achieve this, the spacecraft was put into highly elliptical orbits in order to track Jupiter's poles, to then descend beneath Jupiter's radiation belts and reach 4,100 kilometers of Jupiter's cloud tops. Jupiter spends only 2 hours in the maximum danger zone in each 53-day rotation. The craft spins 3 times per minute, allowing it to collect about 400 slices from pole to pole. Juno is not only photographing Jupiter's intricate surface features but also performing a scan of Jupiter. When scientists look at Jupiter, they see structures that are similar to Earth's atmosphere. Storms pushing upward, anticyclones and jet streams are all visible. Jupiter's weather system and the planet are vastly different. One reason is that Jupiter is much bigger. It also rotates more quickly and is much further away from the Sun's warming radiation. The complex structures found on the tops of clouds' tops offer a glimpse at conditions deep inside. Juno's data suggests that Jupiter's surface flows reach down to 3,000 kilometers. Below that depth, magnetic fields pull the planet into an even rotation, slowing them down. Scientists believe that the inner circle is composed of a sphere filled with metallic hydrogen, surrounded by a solid core made of rock and ice. Scientists believe that Jupiter, a giant planet, formed in long orbits of their stars during the 20th century. These plants can grow by absorbing a rich supply of icy planetesimals. The ice line keeps planets small as there is less solid food in their formative years. Recent exoplanet discoveries have changed this understanding. Along with ground-based systems for the planet hunting, the Kepler space missions have discovered more than 2,000 stars that are home to orbiting worlds. None of them have yet to resemble the solar system. Many star systems' inner orbits are graced by so-called hot Jupiters, large gas giants about the size of Jupiter that whip around their parent star at close range. Some of these gas giants are being stripped by the powerful solar winds. A class of super-rocky Earth is also available. They have twice the mass of our planet and are located in the innermost orbits of many other solar systems. It turns out, the most common plants found in these inner regions don't have any rocky surfaces. It is a class that contains gas dwarfs less than Neptune, and which can weigh as much as 10 Earth masses. Rare, smaller planets of Earth-sized size are actually possible. How did the solar system develop? These planetary shards were dated by scientists using molecular variations, or isotopes, of two specific metals: tungsten and molybdenum. These meteorites seem to be from two distinct populations that formed in different regions of the solar system. Something must have caused a wedge to separate these two regions and prevented them from mixing. The young Jupiter must have grown quickly if this great divider was to have prevented them from mixing. It reached about 20 times Earth's weight within the first few million years of the Sun's formation. Saturn, Uranus, Neptune, and Uranus were their gas giant neighbors. Jupiter could have divided the solar system this way. It would have stopped the flow of matter into the inner system and slowed the formation of large rocky planets and super-Earths. It was then that one of the most significant events in the history of our solar system's history occurred. One set in motion through Jupiter's phenomenal rise. Many new questions have been raised by the discovery of large gas planets in other solar systems' inner regions. Jupiter could have followed a similar path if these massive planets had formed beyond the ice line. To verify this theory, scientists used a supercomputer to recreate the early evaluations of our solar system. They created a program to simulate the interaction of gas and dust, energy, and gravity. This simulation takes us to one corner of the galaxy that was cold and dusty 5 billion years ago. A supernova explosion's shock waves caused the cloud to burst, causing it to collapse into a dense core. It is home to a huge rotating hurricane composed of water, gas, and dust. Its eye is made up of matter that flows along a thin disk into a new star. Light flashes within the disk indicate collisions among larger objects. The orbits of the larger objects are indicated by their concentration rings. Jupiter, which was the first planet of its size to form, occupies a large orbit around the periphery. It is far away from the Sun and has collected huge quantities of ice, hydrogen gas, and other materials. Jupiter reacts within 1 million years to the gravity of both the Sun and the inner solar systems. The grand tack is Jupiter's spiral inward. As the orbit of the massive planet shrinks, it causes chaos in the inner solar systems. Jupiter is known for launching large objects into looping orbits that revolve around the outer solar system, while simultaneously streaming into the Sun. Jupiter is finally attracted to another growing planet, Saturn, and it retreats towards the outer solar system. Jupiter settled slowly back into its current location. This left about 20 to 30 small planetary eggs to guard the inner solar systems. This simulation covers the next 50 million years. As the embryos tug on each other, their orbits are destabilized. After the dust settles, it could be 100 million years later. The number of planets drops to 5. Theia is a planet the size of Mars, which includes Earth. Everything changed after Earth and Theia met. A computer model shows us the first 24 hours. The lies about 1/3 of Earth's distance. Its ashes envelop Earth in shockwaves of superheated vaporized rocks. Earth will be subjected to secondary impacts when a molten circle forms around the planet. In just 1 century, the orbiting ring that surrounds Earth will cool enough to coalesce into a single orbiting entity: the Moon. Earth would spin rapidly on its tilted axis due to the violence of the Moon's creation. One day lasted approximately 5 hours. Over time, the Moon stabilized the planet's tilt and held it steady. Slowly, our planet's rotation was slowed as the Moon moved closer to Earth. The grand tack theory could explain the evolution and structure of the inner solar systems. It may also help to solve many long-standing scientific puzzles. What is the reason Mars is so small? Jupiter is believed to have picked up much of the dust accumulated below the ice line, thus starving Mars. What is the explanation for the different asteroids? It appears that Bennu is a fossil of Jupiter's voyage toward the Sun. This dark object is made of carbon-rich clay material that was formed during the explosion of dying stars. Bennu is also a result of collisions. Over its 4 billion-year journey, the asteroid has likely been pulled apart, stretched, and reformed. Scientists launched the OSIRIS-REx mission in an attempt to trace the origins and return a sample from Earth to the labs. They will send Lucy on another mission to an asteroid group that follows Jupiter. These so-called Trojan asteroids get their names from the soldiers who lived in the huge horse in Homer's Iliad. Jupiter may have been pulling them along during Jupiter's first million years. The main asteroid belt is next. There is a huge hoop of rocks that runs between Jupiter and Mars. Scientists believe that Jupiter moved towards the Sun during the Grand Tack, dispersing a new ring of rocks. Jupiter's return of the Sun caused a new collection of rocks to be drawn in. Scientists are hoping to prove their origin by studying these asteroids' composition, which includes a dwarf planet called Ceres. Finally, the giant planet has its own artifacts that date back to the beginning of the solar system. Many of its 79 satellites are either comets or asteroids captured many years from too close proximity to the giant planet. Different satellites make up the 4 largest. We'd call these dwarf planets if Io and Europa, Ganymede, and Callisto orbited around the Sun. Scientists believe that the moons are slowly formed from a disk made of ice and other debris that was very late in Jupiter's formation. All 4 are in the tidal mark. Each one keeps the exact same face towards Jupiter as our moon. Io, the volcanic moon, orbits closest to Jupiter. I am an example of what it means to live too close to a god who doesn't care. Io is continually being turned inside out, stretched, and stretched by Jupiter's gravitational interactions. Io, with its hundreds of volcanoes and lava blasting to heights of up to 400 kilometers, is the most geologically active planet in the solar system. Europa, with its shiny, young, and glossy surface of the ice, is next. Ganymede has a diameter of 5,268 kilometers and is the largest of the solar system's moons. It is larger than Mercury. Then, there's Callisto, 2 million kilometers from Jupiter. The 3 icy moons Europa, Callisto, and Ganymede are all covered in water by spacecraft sensors. Jupiter was formed in the early years of its existence by a disk that allowed ice, dust, and gas to flow into it. Grand Tack predicts that Jupiter's disk would have shrunk with the planet's movement toward the Sun. These 2 larger ice mummies must have formed long before the Sun moved toward them. Europa formed later and attracted less water. Io, on the other hand, had nearly none. Jupiter's major moons did not hoard all the planet's icy bounty. Jupiter would have carried a wave of ice along its inward travel, delivering water that might one day have filled the oceans of Earth. Jupiter and Saturn continued to send more icy material toward the inner solar systems once the outer solar system had returned to normal. Broken ice and rock rained down upon Mars, Earth, Venus, and Mercury. This period can be seen in the lunar landscape today. The late heavy bombardment, a 300 million year long fusillade. According to data from the Moon, scientists have estimated that Earth would have been hit by at most 4 objects. Each object could have turned Earth's entire surface into molten lava. The process of impact erosion, which is crucial for the emergence and survival of life, may have been triggered by these collisions. The impact erosion wiped radioactive metals, such as potassium and uranium, from the planet. The planet's outer crust was able to rapidly cool down, and water could remain. Scientists believed Earth was a water planet during its early years. Juno's spacecraft, which travels at 200,000 kilometers per hour, takes around 2 hours to cross the poles. The Juno spacecraft records various readings of the world, which remains a huge work in progress. Winds that whip around 650 kilometers per hour create swirling clouds of methane sulfide and water. Sometimes, ammonia snow and white clouds fly over the large southern red border, making it appear to disappear from Earth's view. It's cold up there, around -125 degrees Celsius. In the atmosphere, compressed carbon showers may form between layers of diamond rain. The white spots are the crests that mark huge waves rising and falling along its surface. The heat from hundreds of kilometers below causes whirling storms to explode into the upper atmosphere. They unleash lightning bolts much stronger than any other seen on Earth. Juno captured the polar regions, which defied all expectations.